Good evening, friends, and welcome to interview preparation session. And today we'll be going through some of the algorithms and also some of deep learning questions. So yesterday we had discussed logistic regression. So let us take the first question for today. Okay, what is decision tree? So if you know the answer, you can put your answers in the chat. I'll just, yeah, we'll discuss after this. Am I not audible? Hello? Yeah, so the first question is, what is a decision tree? Okay. Yeah, it is an algorithm, correct. Okay, so decision tree also comes under supervised learning. So it is a supervised learning algorithm, yeah, which can be used for both classification as well as regression. Okay, so in this case, uh, the dependent variable can be categorical as well as a continuous value. So that is why it can be used for classification as well as a regression. So the basic structure of a decision tree is like this. So we are having a, sorry, we are having first a root node. This is called the root node, root. Okay, then we are having something known as branch nodes. Whichever is in the middle are known as branch node. Okay, and whatever is present at the end. Okay, these nodes are known as leaf nodes. Okay, So basically all the nodes here, okay, each and every node is a test on an attribute. Okay, so test is like, is it true or false, kind of a Boolean test basically. So if it is true, it goes here. If it is false, it goes here. Okay. So uh, okay, so how do we decide which attribute to take as a node? Yeah, Shalini, you are correct. So how to decide which node to take? Okay, before that, just answer me. What is entropy? Let's take the next question. What is entropy? What is entropy in decision tree? Yeah, decision tree could be used for classification as well as regression. Okay, we decide based on entropy. Okay. Okay, so this entropy, we can call it as a measure of impurity or randomness in a data set. Okay, so the entropy of a data set tells us how pure or impure this values of the data set are. And if we tell in simple terms, we can call it as the means it we, yeah, basically it tells us about the variance in a data set. Okay. Yeah, correct. Sure. So let's take another important question in decision tree. What is information gain? So what is information gain? Okay, let me tell you. So information gain, okay, for knowing the information gain. So what happens in a decision tree? At each step, okay, we have to decide which attribute to take as a node to split the data. Okay. So for choosing this node, okay, we'll have to choose the feature, okay, feature having the smallest, uh, not the smallest, the highest information gain. So what is this information gain now? Information gain is like the entropy after subtracted by the entropy before, uh, uh, means a node. So after this node is split, what is the entropy of this column? And before it is split, what is the entropy? Yeah, we can say that, Shalini. Amount of information improved in the nodes before splitting them for making further decision. Yeah. So basically it is entropy. Yeah. Hmm. So to make this, to choose this column, which we'll use for deciding which column to take as a node, we'll look for the best information gain. So whichever column is having the best information gain will be chosen as the present node. So if a root node, so we'll check all the columns. So whichever column is giving us the best information gain, okay, we'll be taking that column as our root node. Then after root node, we'll be dividing again, we'll be splitting the data. So something like yes, no, we'll be getting here. And again choosing, suppose this is the second node we are choosing. So again, we'll check which one has the highest information gain. So now this column is excluded. So excluding this column, with all the other columns will now be checked. Whichever is having the highest information gain, yeah, whichever is having the highest information gain will be again considered for this node. Again, the next node. Okay, like that we select the nodes. Okay, now what is this information gain? Information gain. So before splitting this node, we first see what is the entropy of this column. Okay, and after splitting, what is the entropy we check, and we just subtract this two values, and that is the information gain. Okay, so whichever column is having this value greater is taken as the node. Okay, I hope it is clear. Okay, coming to the next one. What is ensemble learning? Okay, so this ensemble learning. Okay, so what happens when suppose we are building a machine learning model. Okay, so our generally our goal is to generally our goal is to uh, uh, find out this underlying patterns or trends in the data. Okay, so sometimes what happens, sometimes the data set are too complex. Okay, and it is very difficult for one model to be able to capture the trends or patterns, we can say. Okay, so in that situation, in that situation, what we can do is we can combine several individual models together. Okay, to improve the performance of this model. So this combination of individual models together to improve the performance of algorithm, it is known as ensemble learning. Okay, in statistics and so on. Yeah, correct. Yeah, Salini, you are correct. Now coming to the methods used in ensemble learning. So coming to the first one, what is bagging? What is bagging in ensemble learning? Okay. Yeah. So yeah, correct, Charan. Bagging is also known as bootstrap aggregation. So what is this bootstrap aggregation? So let us know what is this method. So what happens in this method? Okay, we we use this data. Okay, to generate multiple samples of suppose a size. Okay, so these multiple samples of suppose n size are known as bootstraps. Okay, or you can say bootstrapped data. Now what we do, all this bootstrap data, so basically this is converted into small subsets of data. And what we do, we train multiple models in parallel on these data. So small data, okay, subset of data, we train multiple models in parallel. So what it does, okay, it makes the bagging model robust. Okay, so because see here, on the same data, multiple models are being trained. So on the suppose on a first bootstrapped model, we are training suppose if it is a classification, suppose so KNN, neighbors, all that we are training. So whatever models we are choosing, we are using all those models to train on a single bootstrap data. Okay, and once all the models have been trained, okay, we make predictions. Means suppose if it is a classification, so the prediction is like the highest frequency value whichever we are getting from this models. Okay, and if it is a regression, what we do is all the trained models, we take the average value from all the trained models. Okay, so this way we do bagging. Now coming to the next one, what is boosting? Okay, so this boosting is also like bagging, but means also like bagging in the sense that we make certain subset of data we take, but unlike bagging, okay, here we do not train our data parallelly. So what we do, we create multiple models and sequentially train them by combining weak models iteratively, okay, in a way that that training a new model depends upon the models trained before it. So what we do, suppose we are training a first model, okay, so whatever we get the output from it, okay, we keep that and we again train. So we keep that information and further train with another algorithm. Okay, so what happens in if we do like this, we take all the patterns which are learned in the previous model, okay, and we test them on the uh, you know yeah, basically it is trained sequentially, so one after another we are just giving different algorithms and training the same data, and we are just taking the all the patterns learned by the previous model and we are testing them on the data set when we are training on the new model. So what happens in each iteration, so each iteration we are having a different model being trained. So what happens in each iteration, we give more importance to the observations in the data set that are means not correctly handled by the previous model. Okay, so whichever column, to make it easier, I'm just saying it column, so whichever column is incorrectly handled by the previous model, this model gives more importance to that columns. Okay, now coming to next question, what is stacking? So this is also an ensemble method. Okay, so in stacking, okay, in stacking, generally in bagging and boosting, we use only one learning algorithm. Suppose we are using logistic, so on all the weak models, we'll be using logistic regression. Okay, if we are using KNN, we'll be using KNN on all the weak learners. That those are called the bootstrapped models are called as weak learners. Okay, so in bagging and boosting both, we use just a single algorithm on all of the data. Okay, but here in stacking, what we do in stacking, we combine this weak model. Okay, but here what we do, we use different learning algorithms. Okay, we can use multiple algorithms here. So this bagging and boosting are known as homogeneous learners, but this stacking is known as heterogeneous learners because we can use multiple learning algorithms in this. So we can use SVC, then KNN, neighbors together. Okay, all together we can use. And here what we do, we create means this we train on multiple weak models, and then we use them together by training on another by training another model. So what we do here, we create a meta model first. Okay, we create a meta model and make prediction based on the multiple outputs of predictions by this multiple outputs. So we make prediction means every model. So suppose we are having this model, no? Meta model. So it makes prediction based on multiple outputs of the prediction. So it all works internally. So if we just call stacking and we do, it is all working internally. But what it does internally is it make predictions based on multiple outputs of the predictions written by this all the weak models. Okay, so weak models trained with multiple learners. Now coming to uh, an algorithm. Yeah, now coming to algorithm, which is very much loved by our data scientist. What is a random forest? Okay, what is random forest? Ah, yeah, correct, sir. Yeah, supervised ML algorithm. Yeah, correct. So random forest are, yeah. So basically, random forest, you can say it combines multiple models together to get a final output. So it is a bagging model basically. Okay, and random forest have this decision tree as their building blocks. Okay, so a decision tree is taken as a building block for this random forest. So basically, you can say it combines multiple decision tree together to get a final output. Yeah, and correctly, it can be used for both uh, classification as well as regression. So what it does is it uses internally bagging technique along with feature randomness. Okay, and when building each individual tree, it makes sure that the trees are uncorrelated. Okay, it basically can say it creates an uncorrelated forest of trees. Okay, I just forgot one thing. So there is a question about decision tree. What problems do we face in a decision tree? And how to solve them? So while building a decision tree, what is the issue we face? And if we face this issue, how to solve it? Okay, yeah, Shalini, correct. They are prone to overfit, and we can solve by pruning. Yeah, correct. So overfitting is the issue we face in our decision tree, and we can solve them using pruning. So that takes us to our next question. What are the methods of pruning? Okay. So we are having two methods of pruning, pre-pruning and post-pruning. In pre-pruning, what do we do is we tune the hyperparameters. Okay, we change the hyperparameter setting to see if we are getting better accuracy. Okay, if we are means this overfitting problem is getting solved or not, we are just seeing that. Okay, apart from that, we are having also post pruning methods. Okay, so what happens in post pruning is, suppose we have a infinitely grown tree, means a tree with a very large depth. Yeah, yeah, sorry. So if we are having a tree with a very large depth, okay. So in this model, we'll surely be getting a overfitting problem. Okay. So what happens is we do backward pruning. So we calculate from backward. Okay, and whichever you can say whichever node or whichever branch we don't need, we just prune it. We just cut it out, and doing this, we find that we get better accuracy in our means output. Okay, now coming to our next question. So let us take next one as the uh, let us okay, let us ask questions on this evaluation matrix. So what is ROC? Suppose what is ROC? Also AUC. What is ROC curve? What is ROC curve and what is AUC? Okay, so this ROC curve, or also known as receiver operating characteristics curve. Yeah. So it is a plot between true positive rate and false positive rate. Okay, this ROC curve. And this curve is, let me just show you. This curve is something like this. Okay, suppose this is the graph. We are having a true pos sorry, true positive rate. Here we are having false positive rate. So our curve will be something like this. Okay. So what it does, it finds out the right trade-off between this true positive rate and false positive rate. Okay. And it finds out the probability threshold of predicted values. So you can say if the suppose this is the curve, so more closer it is to the upper left corner. Okay, this curve, it is more closer to this point, then our model is better. So this with this uh, curve we can find this out. So how much close this curve is to our left upper left corner, the better our model is. Okay, or we can say, so suppose we are having this and we are having this and we are having something like this. Okay, so this is a better model because we are having this left corner more closer to this graph. Okay, so this is a better model. And also this AUC is known as area under curve. So it shows, suppose for this graph, it is this total area. Okay, so this total area is the area under curve for this first graph. Now this total area is for the second graph, and this total area is for the third graph. Okay, now see, whichever graph is closer to this point, okay, they will have more AUC. So the you can say if a model is having AUC value more, it is a better model. So it is more closer to this left corner. Okay, I hope that is clear. Now this was a evaluation metric from our classification. Now coming to this regression. So what is RMS? Yeah, Shalini, correct. It is an evaluation metric used to evaluate performance of a regression model, basically. Okay, so yeah, correct. RMS stands for root mean square error, and it is a measure of accuracy in regression. So it tells us the magnitude of error produced by a regression model. Okay, so how do we calculate? So we calculate errors in the predictions made by a regression model. So this error is like actual minus predicted. So whatever actual value minus the predicted value, we take the differences as the error. So we take that error, then we calculate the square of this error. So root mean square error. So this square error is being calculated first. After this step, we do the mean of all the squared errors. Okay. Then after doing that, we take the square root of all of this mean. Okay. Hence the name root mean square error. So the error, we take all the errors, we square them, then we take the mean of the all those squared errors, then we do the square root of this mean to get this RMSE value. And one thing, yeah, and one thing to note here, the lower the RMSE value, the better the model. Okay. Okay, now coming to let's discuss something from deep learning. So first question is, what is TF-IDF? So here we start with some questions on deep learning. So what is this TF-IDF? Okay, so this TF-IDF, this TF-IDF stands for term frequency. TF is term frequency, IDF is inverse document frequency. So these two are different measures. Okay, so term frequency, you can say it is the measure of a term, how many times it is present in a document. Okay, so term frequency is the measure of a term, the count of term, uh, the number of times it is present in a document. Okay, now what is this inverse document frequency? So to know this inverse document frequency, we'll have to know what is document frequency. Uh, yeah, sorry, correct. Yeah, so basically IDF is like the inverse log of inverse document frequency. So basically log of 1 by DF, which is document frequency. Now what is this document frequency? Document frequency is like if a term is present in how many documents. Okay, it checks a term, the presence of a term in a in how many documents, means basically the frequency of a term in documents. Okay, so inverse document frequency checks that value, means log of 1 by document frequency. So basically TF-IDF is the product of, okay, term frequency and inverse document frequency. Yeah, if we check this TF-IDF, it will show us, it will give us that how important a term or a word is in a collection of documents. Okay, and this collection of documents is known as corpus. Okay, so, and yeah, so this is basically a thing from text mining. Okay, okay, so let us move on to neural networks. So what is a neural network? Let's take this. What is a neural network? What is a neural network? Okay, so this neural network in our deep learning, or you can say data science, okay, this neural network aims to imitate, okay, it aims to imitate a human brain. Okay, yeah, learner's nest, it is still 5. Okay, so a neural network basically aims to imitate a human brain neuron. Okay, so this human brain neuron, what it does, it combines with other neurons to perform a task. Okay, so you can say it learns the basic generalizations or patterns in a data and uses this knowledge to give us an output, or it can predict an output. Okay, without, means no human intervention is here. So basically unsupervised thing. Okay, and this neural network, in our neural network, the unit of a neural network is known as a perceptron. Okay, so this perceptron is a simplest neural network. It contains a single neuron. Okay, and it can perform two operations, which is a weighted sum of inputs and an activation function. So let me just show you that. So here, just a second. Yeah. So suppose we are having two inputs. Okay, this is input one, this is input two. What it does, first operation is it forms a weighted average. Okay, it gives us the sum of a weighted average. So suppose we are having weight 1 here, weight 2 here, and this is x1, x2, suppose. So it first gives us x1 w1 plus x2 w2. Okay, it gives us this sum here. And on the other hand, we are having an activation function here. So this activation function, we are having a bunch of activation function it can use. and the output from this gets into that activation function, and that through this activation function, okay, through this activation function we get an output. So this input of the activation function is this, and whatever this function processes and whatever output it gives, it is our output of this single neuron, this single neuron, also known as perceptron. Okay. Okay, so friends, with that we'll be closing today's session. It is already 5. So yeah, thank you, and please continue learning. Yeah, and have a good day.